Okay, the first parts we're going to tackle is the hardware. So for this, we're supposed to sketch our multi-views and measure with a caliper, and then try to figure out what size the hardware is. The dowel is ANSI millimeters, so we're going to have to do a conversion to convert that to millimeters. And the thread size are ANSI inches, so we need to figure out what those sizes are. The other part of that is the multi-view should probably look something like this. Of course, we just need a quick sketch, but those are the distances we are looking for. And with the flathead screw, the length is measured from the top of the head to the end of the screw. With a pan head, the length is measured from the underside of the pan head through the length of the screws. And those diameters and screw size should be the same. Okay, just another warning before we go too much further along. Do not assemble the parts, specifically the dowel pin, into the pin slider, because once that is tapped into place, you're not going to be able to get it out in order to make the measurements you need to make. So do not assemble this until you have all your parts sketched and measurements made. Okay? Next, with the hardware, hopefully you found with your conversion that we should be around a 5 millimeter hardware, and depending upon the batch of dowel pins that you got, 20 to 25 millimeters should be the length, somewhere in that range. Wherever I was able to get them the cheapest, there's a pretty good allowance there that would allow that to work, as long as we control how far we tap the peg into the slider. And what we know is those are both 1/2 inch screws, flathead and pan head, with a 0.16 diameter. And screws might look intimidating to model, but actually they're not, because what we can do is find those parts online and import them into Fusion. So first of all, I'm going to be looking for an ANSI inches screw that is 0.16 diameter. That's the major diameter. So I just looked up ANSI external screw thread size and tolerance chart, and there's a bunch of these online. This is the one that I found. So what I'm looking for here is basic or maximum diameter for a screw that is 0.16, 160 thousandths, somewhere around there. And as I'm going through this list, I see that an 832 screw is 0.164. So it looks like that's the right size screw. There are different tolerances, so the screws that we have being 0.160 are probably just a little bit more cheaply made, a little bit more slop in them. These are a much tighter fitting tolerance. So, and that goes by the class of thread that you have. So we probably have 1A threads where these are 2A or 3A. Okay, so I know I need 832 1/2 inch. So then what I'm going to do, I'm going to go to McMaster Carr. Okay, and I've got screws and bolts at McMaster Carr, and I need a rounded head screw with a Phillips head, steel pan head Phillips. There we go, right here. Steel pan head Phillips. Thread size, I need an 832, and the length is 1/2 inch. Okay, so then I can go to my parts, and I'm going to select from the drop down a 3D step model to download. So I'll go ahead and select download, and that's going to download to my downloads folder. Let's go back, we'll clear all that, and then we want to find also a Phillips flathead screw. And again, we just need the basic steel. So we need I picked 632 and said 832. There we go, 832 1/2 inch long. And we want the one with the 82-degree countersink angle. That's more common than the 100-degree. We can also see that by the price. Okay, so that's our basic countersink flathead screw. Download that step file as well. And then I'm going to go back to my home page. And I'm also looking for a steel dowel pin. So I'm going to go into pins. There's just a basic metal dowel pin. That's the first one that pops up. I'm looking for metric, diameter of 5 millimeters. And length, I get options for length from 20 to 26 millimeters. So we'll just go with the 20 millimeter. And I just need regular alloy steel. We don't need these to be stainless. So we can do that. And we can download that file as well. Okay, so those are all now downloaded. Okay, now I want to go to Fusion. Make sure I'm in my Trammel Toy Project folder. Might have had to create a new project file. And then I'm going to identify where I downloaded those files. And I probably want to rename these and make those a little bit more intelligent name. So I'm going to just right click and select rename. I need to be careful not to delete the .step because that identifies this as a 3D modeled step file. So what is this? This is an 832. So I'm going to use underscore. You don't want to use a dash or a hyphen. 832 panhead Phillips by 1/2. So I'm going to use underscore because it would be bad practice to use a decimal point in that name or something like that, or a slash. So that's a little bit more descriptive that I have an 832 panhead Phillips by 1/2 inch long. Okay, I'm going to do the same thing with my flathead. So I'm just going to rename that 8_32 Phillips flathead by 1_2. And then the dowel pin, we'll go ahead and rename that one. That's a 5 millimeter dowel pin by 20 because we were 22 millimeters long. Okay, once I've renamed them, then I'm going to go ahead and upload, select the files, and I'll select all 3 of those and click open, and then click upload, and just wait for those to refresh. And then I don't have to model those 3 parts because we would not need to do that. We would just source any hardware with what's readily available. Okay, that was easy. Just took a moment or two for that to upload, and we have the 3 pieces of hardware.